All right, Chem team, here's your next installment, and this is over Dalton's law of partial pressure. This is a relatively simple law, but it's something that we should go over pretty quickly just so you have some experience with it. So here we go. Dalton's law of partial pressure tells us that if you mix any gases together and find the total pressure of the gases, they would be equal. That total pressure would be equal to each individual pressure of the gas. So basically all you're doing is you're taking all the mixture of gases and you take every individual gas and add up their pressures and you'll get your total pressure inside your container. And we're going to talk about Dalton some more next week when we start looking into atomic theory and how he kind of started the whole idea of the atom using science and data to go with it. So if we look at our example here, you're going to see a pressure measurement in a unit called torr. And so if we have oxygen and nitrogen, the oxygen itself has a pressure of 200 torr. The nitrogen by itself has a pressure of 330 torr. If we mix them into the same container, they both started in the same size container. If we put them both into one container, all we would do is we would just add those two together. And what we end up with is our total pressure of 530 torr. So 200 plus 330 gets us 530. So that is it in a nutshell. The questions will get a little bit trickier than just simply adding them together. Let's take a look at a couple. All right, so the mathematical equation that goes with it is that you're going to see the P and then TOT, which stands for total pressure, equals P1 plus P2 dot dot dot, which tells you that P1 and P2 are different gases, and that can go on for however many gases are in your sample. You will also sometimes see it as your total pressure is equal to X1 times P total, or total pressure, and that X is going to be a mole fraction, or your percent of your total, what percentage that gas makes up. And when we write that percentage, we're going to write that as a decimal. So you can multiply your percentage times the total pressure. All right, so number one, if you have a 441 liter container of nitrogen gas under a pressure of 88.3 kilopascals, and you add some oxygen gas until the total pressure of the mixture is 213.9 kilopascals, what is the partial pressure of oxygen? Well, right away we can write out the pieces that we know, and we know that we have a total pressure of 213.9. That's going to be in kPa. All these units need to be in the same for each individual problem. So if we're using kPa for one unit, we're going to use it for all of them. So total pressure 213.9. The pressure from our nitrogen, I'm writing that as N2, and we'll find out later why I'm writing that as N2, but the total pressure for nitrogen, or just the partial pressure for nitrogen is 88.3. And the question wants to know what is the pressure of the oxygen that we added to our container. So the PO2, the pressure of oxygen, what is that? So the easiest equation that we have up there is that we know that our total pressure is going to be equal to the nitrogen pressure, partial pressure, plus the oxygen. So we're going to plug in the values we have. We have 213.9 for a total equals 88.3 plus our partial pressure for oxygen. So yes, all we have to do here, this is that easy, since we are adding on the right side of our equation, is isolate the partial pressure of oxygen, is subtract 88.3 from both sides, and when you do that, you end up with a partial pressure for oxygen that is equal to 125.6 kPa. So when you see problems like this where they're just giving you pressures and a bunch of gases, they're relatively easy as long as you can figure out which one is which in terms of looking for the total pressure and each individual substance that's involved. All right, let's take a look at number 2, which is a little bit trickier. Number 2, if you have a mixture made up of 25.6 helium gas, 31.2% argon gas, and 43.2% neon gas, which exerts a pressure of 1.54 atmospheres in a 3-liter container, what is the partial pressure of each gas? So what they're giving us here is they're giving us a mixture of gases and not giving us each pressure, but instead giving us what percentage was put into the container. So if we know that this 1.54 is our total pressure inside our container, we're going to have to use the rest of that information to solve for the partial pressure of each. And so what we're going to do, since our total pressure is just a sum of all of the mixture, we can take that percentage and multiply it by the total to figure out each piece. So let's go ahead and check that out. So let's start with our helium. So if we wanted to find the pressure of just the partial pressure of just the helium, what we're going to do is we're going to take that percentage for helium gas and we're going to turn it into a decimal. So whenever we take a percentage and turn it into a decimal, we're going to move it 2 spots to the left. So that ends up becoming 0.256, and we're going to multiply it by the total of 1.54. So that means our partial pressure for just helium is 0.394. And we're going to do the same thing for argon and neon. So the pressure of just argon, again, make sure you take that percentage and turn it into a decimal, so that becomes 0.312. Multiply it by our total, which is 1.54, and we get a partial pressure of 0.481 atmospheres. And the last one, which makes up the highest percentage of our container, which is neon. So we should see a higher partial pressure since it has a higher percentage. That gets turned into 0.432% times 1.54. And when we multiply those together, we get a partial pressure for just neon at 0.665 atms. So those are the 3 individual pressures for the gases in this container. You can double check and make sure your calculations are correct by just adding all of these together. And if you were to add all of those together, they should bring you right back to that total pressure of 1.54 atmospheres. Okay, so overall, this is about as tricky as these problems get, where they would give you different percentages and to solve for maybe one or all of the different partial pressures. You can do any of these with a little bit of problem solving and using some of those basic algebra and math skills that you've developed over time. So good luck and bring some questions into class. We'll talk more about this tomorrow.